Welcome back. We're at GDC. My name is Desiree, and this is John T., and we're here live.
Hi, nice to meet you. Yeah, I'm John Thewitt. I'm part of the Azure Specialized Compute Group. I'm what they call an industry program manager. We're focused on big compute in the cloud and big workloads like rendering, for instance.
So John, what is rendering?
So rendering is generating an image from a 2D or more generally, commonly a 3D model. There's what they call the data input structure, which consists of viewpoint, geometry, texture, lighting, shading, and other data, and you take that data input and create an image. Or as I like to tell my mom, it brings models to life. And rendering is by far the most compute-intensive, complex process in a complete production process. If you were to look from storyboard to final end production and count up all the compute core hours consumed, rendering would be close to 90% of those compute hours. It's very distributed, many dependencies between the render jobs and the data sets. And hey buddy. It's all right. No problem.
We are live.
We are live. Yeah.
So who uses rendering?
You know, a lot of different industries use rendering, and different industries use different types of rendering. So to take a little step back, I mean, the two big differentiators or different types of rendering would be considered real-time and offline. Real-time would be used in interactive gaming and stuff like a lot of folks are talking about here at the show. And you're talking about response times in milliseconds. Offline rendering, sometimes you're talking 24 plus hours for a single frame to be rendered. Sometimes double that. Obviously that's not going to work in an interactive environment. And then within rendering is just different types like rasterization, which is more geometry with based on elements, usually triangles, and that's for speed and efficiency. Then there's things like ray casting, ray tracing, which have a specific viewpoint and different sophistication in how they're using optical information. Then there's another like radiosity, which is pixel by pixel. There's no camera viewpoint. And it uses, it's more surface-based, and uses, accounts for indirect illumination very, very well. And oftentimes these different rendering techniques are used in combination with each other for depending what result folks are looking for.
So John, why would someone want to render in the cloud?
It's for the same reason folks use the cloud for pretty much any application, and you know, across industries, different applications, whether it's manufacturing, financial services. One is the scale, tens of thousands of cores available, you know, at your fingertips, so to speak. The elasticity of scaling those cores up and down as you need them. And only paying for which cores you're consuming, so pay for use. Also the reach and location. Azure has 42 data centers itself, and the more prevalence of remote workers, artists, you know, get the best worker wherever they might be, and there's a data center probably fairly close to where they're located. Hardware selection, always the latest and greatest hardware is available. So you don't have to go through your capital depreciation before you upgrade to the next revision level of your CPUs and GPUs. No infrastructure or less infrastructure costs. So you don't worry about the space cost, the heating, the cooling, the maintaining of those assets.
Why might a customer want to render in Azure?
So I like to think of Azure as a platform. I mean, it's of course your underlying hardware, and then your virtualization, I'll call it your cloud services, you know, your IaaS, PaaS services, whether it's OS, middleware, or runtime. And then you have your actual applications on top of that, whether it's end user or development. But between those, you still need to define, configure, and manage your infrastructure. And that's where we have tools, I think, that set us apart. Tools like Azure Batch that takes care of all the plumbing between the, I'll say, the cloud services and the app user. We have Azure Batch rendering, which takes that a step further and gives you pay-per-use licensing, so an end user can have a single bill, a single interface. And we support major renders like V-Ray, Arnold, and other products like 3ds Max and Maya on modeling and other input. We've also recently acquired CycleCloud, which has a complete end-to-end workflow solution. Very good for hybrid environments, very good for IT organizations that want to have control over different projects or jobs or games. Let you manage and audit and control the spend and access to how many cores at a time.
Great, thank you. And last question, I swear. Can you give me an example of a customer using Azure?
Let me talk about Jellyfish, who's a VFX shop in the UK. We've done a lot of work for them, and I pulled up, I have a quote from Jerry C. Smith, who's their CTO. And he has a 2-3 sentence quote that I think encompasses a lot of the value Azure brings. So if you don't mind, I'm going to read it. The beauty of Azure GPUs is that we get a top-end GPU at our disposal. That right there is, you got the most latest up-to-date GPUs available without going on and purchasing and benchmarking them on premise. Paid for by the minute, hour, and week. Took advantage of pay-per-use. As you scaled up, you paid for them. As you scaled down, you're not paying for them. If I hire 10 contractors for a month, I don't have to buy them dedicated workstations, a savings of tens of thousands of dollars. And the elasticity of your business process, also not explicitly stated in that those artists could be anywhere, located anywhere in the world. And by using HPC resources in Azure, we have a lot more confidence in going after big jobs. So they're not limited by the on-premise compute and IT capabilities. They can scale up bigger jobs, more jobs simultaneously, finer instantiations of the same job.
So great, thank you so much.
All right.
This is John T, I'm Desiree, and we'll be back with you soon.
Thank you.
Live from GDC.
Live from San Fran.